Hiya. Okay, so we're on our final video for structure and function of the heart. So this is section 4. If you have been struggling with this so far, and say during the National 5 recap areas, you've been finding that you've been struggling a little bit, I'm going to remind you we do have a Nat 5 channel where we are placing stuff about the Nat 5 course. I imagine in the next couple of weeks we would be putting our Heart 1 up for National 5. So if you want a chance to go through things like the role of the vena cava, the pulmonary artery and vein, the basic structure of it, the coronary arteries, that might be a chance, a good opportunity for you to do it. So we do have a Nat 5 channel. It's a little bit hard to find.
Put the link in the comments for this so as you can find it, but just all of the Nat 5 stuff is there. If you're ever watching any of these Nat 5 review stuff and you think, well, I don't remember that, you can always then go and watch the Nat 5 equivalent of it that we do exactly like this.
Okay, so let's get started on the final video, and the final video is about how do you measure the heart. There is going to be some stuff in this that is just for fun. It's not examinable. We will highlight that, but it might be a good idea. Basically, it's the stuff on wrong ECGs that you might want to skip over if you get to that area.
Okay, so in terms of measuring the heartbeat, so you can measure how often your heart beats. It's quite easy. The doctors do it all the time. You see it on all of the doctor shows. This is the thing that you see quite often. But basically, they measure the pulse rate. So if your heart is missing beats, they can tell, well, something is wrong. We need to do something to fix that. But the main thing that they use to measure your heartbeat is something called an electrocardiogram, which very nicely they shorten to ECG. So this picture here, it shows a nice normal ECG beat. They love a graph question on this.
They love it.
They absolutely love it. So we are going to talk a bit about what an ECG trace actually looks like, so what the graph is, and how you would answer a graph question on an ECG reading.
Okay, so this is the knowledge part of the ECG that you need to know. You need to know what each wave means in terms of what actually is happening inside the heart, so being able to link that. So the P wave, that little blip that you can see there on the graph that's got the P next to it, that is where the electrical excitation of the SA node traveling across the atria happens. Okay, that tiny little change in electrical activity, that is the wave of electricity going across the atria, causing them to contract, which remember is called atrial systole. The QRS wave, so all of Q, R, and S, that big, huge sweep that's happening there, that is electrical excitation of the ventricles. So that there is indicating ventricular systole or ventricular contraction. The T wave, that little sort of sweep up at the last bit there, that is electrical recovery of the ventricles. Okay, so that is diastole. That is where basically electrical relaxation of the heart is happening, where they are relaxing, it causes that T wave. So you do need, in an exam situation for knowledge, to be able to say what's happening at the P, QRS, and T waves. I think it's kind of easy again because they make the kind of shapes, at least the P wave does. It's like a tiny little A to show that it's the atria thing happening. QRS, that's a very sort of pointy V type shape, so that's saying ventricle activity. And then T, if you can just remember, that's diastole, stuck at the end. There's no thing that's representative of that. Don't laugh at me. I think it kind of works.
Yeah, it's fine.
Okay. Do you want me to cover this one?
Yeah.
Okay. So common, very common higher human exam paper is what is the heart rate of this person? So they give you an ECG. They give you a graph that tells you the time along the bottom. In this case, they've just told you the time for each little box and each big box just drawn there on top of the graph. And they're asking for what the heart rate of this person is. So the way that you work through this question is you've got to work out, well, how long is one heartbeat taking? Now, one heartbeat is one complete pattern of an ECG. So what we're looking for is a complete start to end of a heartbeat. So there in green, I've highlighted what one repeat pattern or one complete heartbeat would look like. Okay, so that is all of those boxes, starting from the first green arrow, all of the boxes up to the end of the second green arrow. Now, hopefully you can work out there how now to use the graph to work out how long one heartbeat would be. So we've got there 4 0.2 seconds plus 3 0.04 seconds. Okay, so what we're looking for there is a total of one heartbeat takes 0.92 of a second. To work out how many in 60 seconds, divide 60 by the heartbeat. So 60 divided by 0.92, 65.2 beats per minute. That is the heart rate of this person. If they are feeling very evil, they might ask you to calculate or link it to the cardiac output of this person. So they might tell you that their stroke volume is, 20 centimeters cubed, and then they'll ask you calculate the cardiac output. So there you've got the stroke volume, you need the heart rate, so you work the heart rate out from the graph, and there you have your heart rate, your stroke volume, times them by each other, you'll get your cardiac output. But this is a very common exam question, is basically just what's the heart rate of this person.
Okay, so in terms of abnormal ECGs, now this is the stuff that is not necessarily examinable about, but it's really, really interesting. The link there is also in the sway. It's a really, really interesting video. It's a really cool thing to see. That's why we talk about it. But it's not something you're being examined about, so feel free to just skip this little bit of the video anyway. But in terms of things you can see in abnormal ECGs, so this is an atrial flutter, so basically when there's rapid contraction of the atria, which obviously isn't supposed to happen, the atria contract about 3 times for every 1 ventricular contraction. So when it should be 1 in 1, it's now 3 in 1. So it's showing here lots of little bumps to show the atria contracting, and then obviously your big kind of QRS wave. I was going to say PQRS, and then I was like, no, I can't remember the right letters. But your QRS wave is the big kind of point. The little ones are all your atrial
P waves.
Atrial contraction. So there's a video. The link is in the sway, so you can have a look at that. It is really interesting to see.
Okay, this is what ventricular tachycardia looks like. So it's
when they talk about V-tacking, like Grey's Anatomy and things, it's this.
It's when the ventricles read rapidly and independently of the atria. What this does basically is it causes loads of QRS waves that are a bit weird looking. So if we see this pattern, again, we can identify this person's ventricles are not beating properly. And again, that video link, if you click it on this way, it's just showing an example of what ventricular tachycardia looks like. The next one is the best video ever.
This is ventricular fibrillations, which I think that's what my dad had.
VFib is what they call it in videos.
So uncoordinated electrical activity of the heart. So basically, your heart doesn't know what's happening.
It looks like a toddler's got control of the line. Just randomly.
It's when basically no pumping cannot take place. It can be fatal if it's not corrected. And defib, so electrical shock, is the only way that can fix it.
If you are on this way and you click that, like, it is amazing. It's basically during live surgery, a heart that's going through VFib that you can see it's just jiggling. It's not contracting at all well. When the 2 paddles go in, they do defibrillation and they shock the heart. You can hear the little beep of the little shock, and then suddenly the heart starts beating correctly. I absolutely nerd out like crazy at this video. I think it's fantastic, but warning, it is gory, which is why you do need to sign in order to watch it, because you need to verify that you're over, I think, 15 years of age for that one, but it's brilliant.
Atrial fibrillations is what my dad had.
Yeah.
Just remember that, just in case he for some reason sees this and thinks that's not what happened.
Right, so end of non-examinable part. We're moving into blood pressure, which is examinable. Yes. So this, you can get exam questions. So another indication of the activity of your heart is your blood pressure. This is a direct measure of how hard your heart has to work to push blood around your body. So how hard is it working while you're sitting still in order to get the blood all around your body?
Okay, so when your blood pressure is being taken, there are 2 different readings. There are systolic, so your pressure when your ventricles are contracting, and diastolic, the pressure when your heart relaxes, so when it's in diastole. So this gives the reading that you usually see on your blood pressure meter. So when you've got the value on the top and the bottom, that is to do with systolic and diastolic. So you get these 2 readings, and this basically tells you what is the maximum pressure your blood vessels can withstand and what is the minimum pressure that they can drop to.
Okay, now how a sphygmomanometer works. A sphygmomanometer is a heart pressure meter thingy, okay? You do need to know that word because we've had prelim questions that have cropped up asking you to name a sphygmomanometer, okay? This is how it works. Number 1, you put the cuff around your arm and it's inflated, and what it does is it cuts off your arterial blood supply down the arm. The pressure is so hard that it cuts off that deep artery that is inside your arm. Step 2, the cuff slowly deflates until the blood starts to force its way, by your heart beating, it starts to force its way down through your arm by the ventricles contracting. You can hear a pulse at this stage in your arm. So if you've got the old-fashioned ones with the stethoscope and you're trying to hear it at the elbow type area, is you should be able to hear basically a thump, thump, thump. That is your systolic blood pressure. That is the hardest that your heart is contracting, being able to push blood through your artery. The cuff will continue to deflate and the artery will, I just need to cover this so I can actually read it. The artery will fully open at another pressure. So this will basically say your artery is now at normal pressure. What happens there is the pulse will disappear because you're constantly getting blood flowing through your artery. So you will not be able to hear the pulse anymore. That will be diastolic blood pressure. So that is the minimum blood pressure that your heart is actually working at this time. Okay. Now, Systolic blood pressure tends to be temporary. It tends to be very short-lived. Your blood pressure systolic can temporarily go really high if you're super stressed out or exercising, and it can drop quite low if you're quite relaxed. Diastolic blood pressure tends to be about the same all the time. So diastolic blood pressure is a good indication of, are you well or are you not well?
And you can get an essay on this stuff. There was one last year in a prelim. It was a bit mean because they never used to ever ask about this stuff. But the bonus is, it's really, really easy to get the marks. Like, you've got a mark for saying sphygmomanometer. You get a mark for saying the cuff inflates. You get a mark for saying the cuff then deflates. And then you got your other marks for obviously relating it to the knowledge that you had. But it was a 5-mark essay. You got 3 marks for saying sphygmomanometer, cuff inflates, cuff deflates, which was 3 out of your 5 marks. So it is a nice one technically, but here's a diagram again. It shows it basically shows the process that you would do if you were using the thermometer and kind of what your arteries look like at various pressures.
Okay, now hypertension, these are facts that you do need to know. Normal blood pressure is 120/80 millimeters per mercury, millimeters of mercury, that's basically. mmHg is the measure of pressure that we use. You do need to know that number. It comes up in multiple choice questions. Make sure it's this way around as well. It has to be the bigger number over the smaller number. I know how to talk. Hypertension is a diastolic blood pressure that is higher than 90. So that second number, if it's higher than 90, you have hypertension. And what that is that's chronic high blood pressure. High blood pressure is bad because it can lead to conditions such as coronary heart disease, stroke, atherosclerosis, which we will learn about in cardiovascular disease, the next key area, problems during pregnancy as well. So you do need to have an awareness of 1 or 2 things that high blood pressure can lead to in terms of badness.
Okay, so to summarise, measuring the heart activity, there's 2 different techniques we talked about. We talked about the ECG, so that is the thing that shows the electrical activity of the heart. It shows that nice PQRS wave that we showed you in the graph, which shows systole and diastole. Irregular waves can also be, or irregular heart problems can be shown by irregular waves on the ECG reading.
Okay, and then you've got your sphygmomanometer, which is your blood pressure meter. It shows blood pressure, so how hard the heart is working. Normal blood pressure is 120/80. The sounds heard during the technique are the opening and closing of the artery under various pressures of the cuff. So that is the end of heart stuff. There are 4 videos, a lot of content covered in there. We know, again, our advice would be look over your PLPs with the ticky box sheets of essential knowledge that you need to go through. It would be find all the past paper questions. They're all available on your Google Classroom to have a look through and practice them, including the essay questions, which can be quite nice about describe the control of the cardiac cycle. They're quite nice ones for that.
And know your Nat 5 stuff, yes. Because if you struggle with a lot of this, if you at least you know the Nat 5 basics, that is a good start because a lot of it actually just builds from that, which is quite nice about it.
And if you're struggling, do not forget to ask your teacher, get them to go over stuff. Make sure that you're getting help with this stuff. It's not the easiest stuff in the world. It is quite nice, but yes, making sure that you're knowing this content really, really well. Good idea. Okay, the next key area is all about cardiovascular disease. So if we take arteries, capillaries and veins and the heart and we look at what stuff goes wrong with them, that is cardiovascular disease.
It's cool, it's interesting, it's a bit minging though.
It's quite minging, but we'll see you then.